Simply put, topology is the mathematical study of properties that are preserved through deformations, twistings, and stretchings of objects. Tearing is not allowed. To truly grasp complex topological concepts, you need to understand the difference between an edge and a surface. An edge of a polygon is a line segment that joins two vertices. A surface of a polygon is a 2D shape enclosed by three or more edges. Other minor things you may need to know is the definition of area and volume. Area is the amount of space inside of a 2D surface, and volume is the amount of space inside a 3D shape. This is a Mobius strip. It is an extremely interesting shape which awes topologists. To make a Mobius strip, take a piece of paper, give it a twist, and join the ends with a piece of tape. The original rectangular strip of paper has 4 edges and 2 surfaces. When you turn it into a Mobius strip, it has 1 edge and 1 surface. You may be thinking, wow, that's pretty cool, but what good is it? The Mobius strip is the building block of many theories and concepts that are simply out of this dimension. If you can take an object such as this strip of paper that has 4 edges and 2 surfaces and make it into a Mobius strip with 1 edge and 1 surface, what will happen if you take 2 Mobius strips and put their edges together? What will happen? To truly grasp what would happen, you need to understand different dimensions and how they work. We'll start at dimension 0. There is no movement. You can represent it with the dot. Next up is the first dimension. We have movement in one linear way. This can be represented with a line. For demonstrational purposes, we'll call this movement left and right. In the second dimension, we now have another direction to move. We'll call this movement up and down. These two axes are perpendicular to each other all the time. In the third dimension, we have another movement, and we'll call this one back and forth. Now this is where it gets tricky. In the fourth dimension, you add another way of movement, and all of these axes are still perpendicular to each other. This fourth linear movement is called ana and kata. Now that you know how many axes and directions each dimension goes, I'll explain 2 analogies. When you take this one-dimensional shape and shine a light on it, you'll get a 0-dimensional shadow of this point, which is a dot. When you take this 2D shape and shine a light on it, you'll get this one-dimensional line as its shadow. When you take this 3D box and shine a light on it, you'll get this 2D rectangle as its shadow. But when you shine a light on a basic 4D shape such as a hypercube, you will get a 3-dimensional shadow. If you didn't understand how they connect through the shadow analogy I just told, hopefully this will help. When you unfold a 2-dimensional rectangle, you'll get a 1-dimensional line. When you unfold a 3D cube, you'll get 6 2D squares. When you unfold a 4-dimensional hypercube, you will get a 3D object called a tesseract. Every time you unfold or cast a shadow of a dimensional object, you will get its unfolding or shadow in the dimension that is 1 less than its own. The unfolding analogy is important because it makes understanding the concept of extremely long travel in short amounts of time very easy to understand. An example, I'll take this unfolding of an object, and in theory, if we were here and need to get all the way over here, that would take a long time to travel. But if we were to go from this lower dimensional unfolding and go forward into the next dimension and refold this, we would be there in a fraction of the time. This is why extremely long distance travel is possible. Bringing us back to our original question, what happens if you take 2 Mobius strips and combine their edge? You'll get what's called a Klein bottle. This object has no edges and only 1 surface. Therefore, its inside is its outside, and it has no volume. A true Klein bottle could only exist passing through the 4th dimension, and here's why. This comes back to the whole idea of how topological objects cannot have holes or tears. The Klein bottle needs to pass through itself without making a hole or tear, and the 4th dimension simply allows for this. To sum it all up, in this day and age, we only somewhat understand the 4th dimension and why the Klein bottle is possible in mathematical terms. If we learned how the 4th dimension works scientifically and knew how to use it, we could time travel extreme distances in a fraction of the time, and even perform surgeries without even touching the body of a patient. If I were capable of using the 4th dimension, I could have finished this entire video in just a few moments of time.